Notebook, let's talk about it. So the example we're going to do will not involve sine or cosine rule, but when you get to question 3, that's when it does. The biggest hint I can give you with these ones is to draw the diagram, and draw the diagram as best as you can. So we have Marie paddleboarding, speed of 7 meters per second north, so she's moving pretty quick. The wind is blowing with an average velocity of 2 meters per second east. Determine the resultant velocity. So we're going to draw a vector diagram here. Up here I'll just put a this. And let's say we're starting here. This is our first vector. We're moving north at 7 meters per second. And the wind is blowing east at 2 meters per second. Okay, determine the resultant velocity. So what's going on? If she's moving north and being pushed that way, this is going to be the resultant velocity. It is her trajectory north plus the wind pushing her east. Okay, so this is R. So let's find R using Pythag. It is a right angle triangle. North and east make a right angle with one another. So R, let's set it out like this. We've got 7 squared plus 2 squared is R squared. Okay, that's 7, that's 2, this is R. And so we'll have R is the square root of 7 squared plus 2 squared, square root of 49 plus 4, square root of 53. Alright. Now with these kinds of problems, it's not really helpful leaving it as root 53, although that possesses every decimal place. We're looking for a unit to declare with it. So I got 7.28. And the unit, meters per second. They're moving at 7.28 meters per second. But they're not moving north. They're moving this sort of northeast direction. And so that's the next part. Find the resultant velocity. And what we might do to begin with, we might determine the direction of that velocity as well. Okay? So that means that's the angle we're trying to find. All right, we've got theta in there. We're saying what's their bearing. Okay, so they're not going straight north like they had initially intended. They're being pushed along by the wind. So this is again a right angle triangle. I might put the 7 on this side. And so you can see we've got, if we were to label it, here's our hypotenuse, this is our opposite side, and this is our adjacent side. And so if we're trying to find theta, let's remember Sohcahtawa. And we have all the sides now, but let's go with the sides where we haven't rounded anything. Okay, we've got, this is 2 and this is 7. So we've got O and A. And so let's make the statement tan of theta is equal to O and A. So that's going to be 2 on top of 7. All right, and then we do inverse tan to find theta. Tan minus 1 of 2 on 7. And I've got 15.94, 15.9 degrees. Okay, so the resultant velocity is 7.28 meters per second at an angle or a true bearing of 15.9 degrees, 15.9 degrees from true north. Okay, part B, what bearing will she need to maintain in order to move directly north? Okay, so fortunately for us, we've found this angle here, and let's draw a new diagram. If you want to move, this is what she wants to be her resultant velocity, is directly north. Okay, the wind is pushing east at 2 meters per second. Okay, so that means this is the direction she's going to need to move with her, she paddles on her paddleboard at 7 meters a second. So the question is, what is her bearing? Now remember, bearing is always from north clockwise, so we need to find that angle there. Okay, that takes us back to year 10 when we talked about true bearing. Right, that's going to be our bearing there. Now, really, this angle here, okay, this angle here is the same as the angle we found in here. Okay, it's just on the opposite side of it. We're moving 7 that way and 2 that way. This angle here is going to be 15.9 degrees. Hang on, no, we can't declare that. We can't declare they're the same. Let's call this phi. We can't declare they're the same because it's the hypotenuse, not the adjacent side. Excuse me, getting ahead of myself. So let's go through and label this. We're moving 7 that way, 2 that way. We need to find what is her resultant velocity and what is the angle that she's going to need to move in. Okay, so let's find this angle first. Let's find phi here, and then we're going to do 360 take phi to get her bearing, and then we can do Pythag to get the value of r. So let's label the triangle. This is our hypotenuse. This is our opposite side because this is the angle. This is our adjacent side. So we're looking for a ratio involving O and H. Okay, O and H. That's going to be sine. So we have sine of phi is O on H. We'll make that statement. Sine of phi is 2 on top of 7. All right, and then inverse sine. Phi is the inverse sine of 2 on 7. Okay, I have not calculated this one. All right. Shift sine 2 on 7. 16.6. So it's close to our angle, but not the same, is it? Okay, so then our true bearing is going to be 360 degrees. Take away our angle phi that we found here. So what will that be? 343.4 degrees. Or 343. Okay, so that's the angle that she's going to need to move at in order to head directly north. What's the resultant velocity? Here we can just do some Pythag. We've got r squared plus 2 squared is 7 squared. We've got r is going to be the square root of 49 take 4, which is the square root of 45, which is 6.7 meters per second. Okay? So if she wants to head north, she's going to have to paddle into that wind a bit, which is why it's going to slow her down. Rather than moving at 7 meters a second, she's going to be moving at 6.7 at an angle of 343 degrees at true bearing. Cool. All right, so with these ones, draw the diagrams, okay? Draw the diagrams, and then we're creating triangles. The first two are just basic right angle triangles, reasonably similar to what we've done here, and then you get some complex cosine rule. All right, so exercise 3H, let's give it a go.